Glow sticks. They're a must-have item on rave scene and at parties, a novelty item at Halloween, and a light for scuba divers underwater. They are also used by rescue teams in times of natural disasters because they require no electricity to provide light and glow sticks generate no heat. Because of the popularity of glow sticks in modern times, we were interested in the type of chemical reactions involved and how the environment could change its effects. From our research, we were able to fully understand how a glow stick is able to produce the light it creates. The chemical reaction involves chemiluminescence, the production of light as energy. In a glow stick, a glass vial contained hydrogen peroxide, and a plastic tube outside the glass contains diphenyl oxalate and a type of fluorescent dye. When the glow stick was bent, the glass was broken, and the hydrogen peroxide and the diphenyl oxalate were mixed, hence creating a reaction causing the diphenyl oxalate to be oxidized and for a peroxyl acid to be produced. Peroxyl acid quickly decomposed to form carbon dioxide and released energy to the fluorescent dye, which was excited to give off protons as energy. By understanding the reactants involved within this reaction, we were able to narrow down what type of lab we were able to create. As the reactants involved in such a reaction was too expensive, we were not able to create a glow stick as we originally intended to, and had to stick to a different experiment. From the research we have done, we recognize that even if the reactants remain the same, the final results of the reaction can be altered by the temperature of the area where the reaction takes place. Hence, we decided to understand the effect temperature has on such reactions. The purpose of this experiment is to determine the effect of the temperature of the surroundings of a glow stick on the intensity of light that is produced by the glow stick. The independent variable in this experiment is the color of the glow stick, the temperature of the water. The dependent variable is the intensity of the light produced. The controlled variable are the size of the glow stick, the amount of water, temperature of the environment, and the lighting of the environment. Our hypothesis is that if the intensity of light produced is related to temperature, then the glow stick placed in cold water will demonstrate a weaker glow, because the coldness in the water will slow down the reaction, making the glow less, and vice versa. In this experiment, we used beakers, a hot plate, 18 red glow sticks and 18 blue glow sticks, a light meter, some ice, and a thermometer. First, we started by putting 150 ml water into each of the 3 beakers, and getting one beaker, putting ice in it to cool it down, and getting another beaker, heating it up using the hot plate to around 50 degrees Celsius, and keeping the third beaker at room temperature. We originally tried to get the beaker which had ice in it to go down to 0 degrees Celsius, but we realized that this was not feasible. We used the thermometers to check that the temperatures were what we expected it to be. After, we went into a dark room, cracked 6 blue glow sticks, and put them into a 0 degrees Celsius beaker, and repeated this step for the room temperature beaker and the 50 degrees Celsius beaker. Then we allowed 30 seconds to pass, and then we measured the intensity of light produced by each of the beakers. Then we got 6 red glow sticks and put them into the 0 degrees beaker, and then repeated that for the room temperature beaker and the 50 degrees Celsius beaker. And of course, we let 30 seconds pass and measured the intensity of light produced. From our experiment, we were able to conclude that as the temperature of the glow stick surrounding increases, the intensity of light which the glow stick produces goes up, and vice versa.